Hello everyone, thanks for tuning into today's video. It's a big day for me, it's a big day for Gas Weather Vids because we're going to be doing the North Atlantic Oscillation forecast for the winter of 2013-2014, and we're basing it on the sea surface temperature anomalies in the Atlantic, but we've had through the course of May 2013. Now, before I go on, I just want to say that this video is going to be kept on my seasonal page here at Gas Weather Vids. It'll be kept there between now and the winter, so you'll be able to come back and enjoy the video whenever you want. Hope you do enjoy the video. Hope you find it interesting and informative. As I say, it's going to be kept on my seasonal page between now and the winter. So yes, come back and watch it whenever you want, and do enjoy it. So we're going to start off with a good example of a positive NAO. Should just explain before I go on with this. But if you know what the North Atlantic Oscillation is, and you know about the connection between May and the subsequent winter, then you won't really need to watch this first part of the video, so just skip on to the bit where you get to the forecast. That's a bit for you. This is just really for those that don't really know about the North Atlantic Oscillation and how May sea surface temperature anomalies appear to reflect what may occur through the course of the winter in terms of the anomalies in the Atlantic and the North Atlantic Oscillation. So we're going to start off with a positive North Atlantic Oscillation, just to say what a positive North Atlantic Oscillation looks like, and this example from the winter of 1989 is a very good example. We've got the area of high pressure sitting to the south of the British Isles around Spain and Portugal, ridging in from the Azores. We've got low pressure around Greenland. You can't see it where I'm highlighting it, but that's a very intense polar vortex, and the consequence is that we've got this strong westerly flow feeding in from the Atlantic through the British Isles in towards Central Europe, and actually going on in towards Western Russia in this particular example. That was a very strong North Atlantic Oscillation. Now, what I should say about this is that the North Atlantic Oscillation is not driving this, it's an index that's reflecting the setup. So in the same way that the Financial Times Share Index doesn't drive share prices, it merely reflects those prices. Well, the North Atlantic Oscillation is the same idea. So the North Atlantic Oscillation in this example is very positive because of that setup. It's positive because we've got high pressure around Spain and Portugal, we've got the low pressure around Iceland and Greenland. That's the reason North Atlantic Oscillation is positive. It isn't a driver, it's reflecting the state of the atmosphere. Now, for a negative North Atlantic Oscillation, where we get a complete reversal in that setup, so instead of having low pressure around Greenland and Iceland, we get high pressure up around here, a big blocking area of high pressure around Greenland and Iceland, extending out of the Arctic. Instead of high pressure coming from the Azores into Spain and Portugal, instead of that we get low pressure down there. And the jet stream, instead of running through Britain towards Central Europe or into Russia, the jet stream is pushing southwards of the British Isles into the Mediterranean, and the jet stream is going that way, taking the low pressure through the Mediterranean, and the consequence is that we pull cold air out of the Arctic down into Central Europe and flood it westwards in towards Britain and Ireland. That's a very cold easterly wind that we have there blasting across the country. A real blizzard actually was going on from an example of that chart for a negative NAO. So that's the difference between the positive NAO and the negative NAO, and why the NAO is important as an index that reflects the weather. So now just have a look at some examples of sea surface temperature anomalies in May, the month of May, that we use to predict the possible NAO for the subsequent winter. I should say there's a little bit of controversy with this. Not everybody really believes that this is a sound methodology. The UK Met Office used to use this, and they used to claim, I can't show you this because a lot of their data unfortunately is hidden away, but they used to claim that there was a 2 in 3 success rate with this methodology for predicting the coming winter NAO setup based on the sea surface temperature anomalies in the Atlantic through the month of May. So it's not a perfect methodology by any means. It does go wrong. We'll have a look at an example in a few minutes of a year that went wrong an NAO forecast that went badly wrong for the UK Met Office. So it's not a perfect example, but it's pretty good. 2 in 3 isn't bad. And just to say why we use May sea surface temperature anomalies, the reason I think really is that in May the Atlantic is more or less at its quietest. We tend to get a lot of easterly winds in British Isles in May because the westerlies are at their weakest really. So that means that you don't get lots of Atlantic storms going on, you don't get lots of big areas of low pressure churning away the Atlantic, and that allows the Atlantic to sort of move towards its natural state in any given year. And the natural state of the Atlantic will be waxing and waning through the year. It's not a constant thing, it's constantly changing. But the state that you get in May, the natural state of the Atlantic in May, is then a pointer to what may occur once you get through towards the winter in terms of those sea surface temperature anomalies. And what we're looking at for a negative NAO, remember a negative NAO is suggesting blocking around Greenland and low pressure going south of it through into southern Europe. Cold winter basically then for the British Isles and for Europe. What you're looking for is a tripole, and this from May 2005. First of all, this example is a very good example of a tripole because we've got 3 distinct bands. We've got a warm band there to the south of Greenland, we've got a cold band going through the central part of the Atlantic around the eastern seaboard, cold band there, and then we've got a much warmer band again going through the tropical Atlantic. By the way, when you get these warm bands through the tropical Atlantic, you very often get very active hurricane seasons, and this was the biggest hurricane season ever recorded in 2005. So yes, we've got a good example of a tripole, warm, cold, warm. You would assume from that the forecast would be a negative NAO for the coming winter, and indeed the UK Met Office did predict a negative NAO for the winter of 2005-2006, partly based on that tripole that was going on through May 2005. Another good example of a tripole is this one from 2010, from May 2010. Again, we've got the warm area there through the tropical Atlantic. We've got a much colder area through the mid-Atlantic and around the eastern seaboard, and then again we've got the warm band there to the south of Greenland. Warm, cold, warm. That is a tripole. Classic example of a tripole, and the forecast from that would be a colder than average winter for British Isles, because the NAO North Atlantic Oscillation would be negative, and indeed the winter of 2010-2011 did have a negative NAO, particularly in the first part of the winter, not so much for the second half of the winter, but that December of 2010 had an exceptionally negative NAO, and the tripole was at least partly to blame for that occurrence. Finally, we're going to look at this example of a tripole in May that would be used, or was used, to forecast a negative NAO for the subsequent winter. And this one's a little bit different. This one is from 1995. What you have to remember about this is that the projection of this is slightly different. So it looks like the areas, the warm, cold, warm areas are different. But basically it's the same idea. We've got this warm area here. That's one area of warm. Then we've got the cold area around the eastern seaboard into the mid-Atlantic, cold there. And then you can't see it particularly well, but we have got another warm area to the south of Greenland. We've got this blue area here. That's wrong, that shouldn't be there, and if you took that away, that's melting sea ice, I think, or something, but if you took that away, you would see that the warm band extends in around there, and again we've got the warm, cold, warm band, but the projection on that is slightly different. But nevertheless, the sea surface temperature anomalies in May of 1995 they were reflecting negative NAO. UK Met Office predicted a negative NAO for the winter of 1995-1996, partly based on that Atlantic anomaly through the course of May, and indeed the winter of 1995-1996 did have a negative North Atlantic oscillation. Now let's have a look at a couple of examples of positive North Atlantic Oscillation forecasts from May, and this is one such year. This is 2006, and we notice with this that we don't have the tripole, so we've got basically one large huge mass of warm water, above average water, stretching from Greenland down towards the Azores. The whole of the Atlantic is basically in quite a warm state, but we haven't got a tripole, we haven't got the warm, cold and warm band. So from that you will predict a positive North Atlantic oscillation. The UK Met Office did predict a positive North Atlantic oscillation for winter 2006-2007, and indeed that's what occurred. So no tripole there for May 2006. Another year that you will predict a positive North Atlantic oscillation from is this one, 2002. This is the anomaly for May 2002. This is the complete opposite of what you would be looking for a tripole, a negative NAO. This is got quite cold waters going through the tropical Atlantic. Then you've got warmer waters up here around the mid-Atlantic, and then you've got more cold water, although right to the south of Greenland is quite warm, but you've got more cold water to the south of Greenland. So that's the complete opposite of the tripole. That's a cold, warm, cold band, if anything, and from that again you would predict a positive North Atlantic oscillation through the coming winter, and indeed the UK Met Office did predict a positive NAO for the winter of 2002-2003, and that is what occurred. So for a negative NAO we're definitely looking for the warm, cold, warm band. The tripole is what we're looking for to predict a negative NAO. If we don't get it, then we're going to be predicting either positive or in some cases neutral. Now I did this last year, just have a quick recap of what happened last year. This was the sea surface temperature anomaly in the Atlantic for May 2012. And what happened there is that we didn't have a tripole. We had a cooler area here through the tropical Atlantic. It was a little bit on the cool side. Then we had warmer area here to the south of Greenland. So we didn't have the warm, cold, warm bands. Instead we had two really areas. We had a colder band, or a cooler band, not particularly cold but cooler, and it was warmer above it. We didn't have a tripole. So from that I predicted that we would be likely seeing a positive NAO for the coming winter for 2012-2013. Now how did that check out? Well, just have a very quick look at this website. You can find this on my links page, by the way. This is a website from Tim Osborne, the North Atlantic Oscillation Index data page. So I'll be putting this up on my links page. This graph is quite interesting here. This indicates the way the North Atlantic oscillation has fluctuated from positive to negative over the decades and the centuries. I might have a look at that another day, actually. I've got time to look at it now. That's quite interesting. It shows the way that we go through these negative and positive phases with fairly frequent regularity. But just have a very quick look at how the forecast from last year checked out, and we can't see the full winter NAO index to show what happened throughout January, February, throughout December, January, February, but we can see December and January, and both months were positive. So if I just quickly highlight them, December came out at plus 0.60, so that was a positive NAO month, and January came out very positive, plus 1.08. That will probably wax a little bit as we go into February. It will probably dip a bit in February, and then of course in March it would crash. March was very negative, but yeah, I think last winter was a positive NAO winter, so I'm quite pleased with how that particular forecast went for last winter. But it was still a cold winter, and what's interesting about this is that the North Atlantic oscillation is only a small part of a much bigger puzzle, and that's what you've got to keep in mind about this, because whilst the North Atlantic oscillation for winter of 2012-2013 was positive overall, it was still a cold winter for British Isles, and the reason that there was a lot of other things going on that I talked about through the course of last autumn. You'll remember it if you was watching the videos back then. I was talking about sea surface, sea ice extent, sea melt, Siberian snow cover, lots of things going on, INSO state, PD radio state, lots of other things to look at. So this idea from the North Atlantic Oscillation, it doesn't mean that if it's positive, it doesn't mean that you're definitely going to get a mild winter. It doesn't mean that if it's negative, you're definitely going to get a cold winter. So that's important to keep in mind. Let's say lots of other things going on. So if we have a quick look at a year that went wrong finally, before we get on with the forecast, this was a year that did go wrong in terms of the North Atlantic Oscillation forecast. This is 2009, May 2009, and you would look at this and you will think that the forecast was got to be for a positive NAO because the tropical Atlantic is really quite cool. Then we get this little bit of warm area here through the mid-Atlantic, quite warm there, and then to the south of Greenland it's quite cool. So you would look at that, and the forecast from that would definitely be for a cold, for a mild winter. It would definitely be for a positive NAO setup. And that's what the UK Met Office predicted for the winter of 2009-2010. It was partly based on that, and it went catastrophically wrong because as we go through to the winter, this is the sea surface temperature anomaly that you're going to look at now from the middle of the winter of 2009-2010. This is from January 2010. And look, we've got the tripole. Despite the fact that we didn't have it in May of 2009, we've definitely got it now. We've got the warm band there through the tropics. We've got the cold band through the mid-Atlantic, cold there, and then we're warm to the south of Greenland. And that was a very cold winter, the winter of 2009-2010. It had the tripole in the Atlantic. That was one of the reasons why it was a cold winter. But the prediction from the UK Met Office, based on what was going on in May of 2009, which was for a positive NAO for the winter of 2009-2010, it was disastrously wrong. It's one of the reasons the Met Office stopped doing long-range seasonal forecasts, because they was absolutely hammered by the media for this. The barbecue summer had also gone wrong, of course, and they was absolutely hammered by the media for that prediction for the winter 2009-2010 going wrong. So that just shows you that all these caveats are important, because it shows that what's happening in May doesn't necessarily translate to what's going to happen in the winter, and it also means that even if you get a positive NAO in the winter, as we have had through the winter of 2012-2013, it doesn't necessarily mean that it's curtains for a cold winter, because other things can come into play. So all of those caveats in mind, let's have a look and see what the Atlantic has been doing this May, during May 2013. And the first anomaly we're going to look at is this one from the 2nd of May 2013. So we're starting off in May, and what we've got here is a warm area going through the tropical Atlantic. We've got a cold area going through the mid-Atlantic, and then we've got the warm area to the south of Greenland. So yes, we've got the tripole there. We've got the tripole on the 2nd of May 2013, warm, cold and warm. It's not an intense tripole, not as intense as some of those that we've looked at from 2005 particularly. That's a very intense one in 2010. It's not as intense as that, but it is a tripole. It is a warm, cold, warm band. Let's have a look at further on in the month into the 9th of May, and again it's the same idea that we've got 3 distinct areas. We've got a warm area through the tropics, we've got a cold area through the mid, and again we're warm to the south of Greenland. So again we've got the tripole being maintained up to the 9th of May. Going on beyond that, this takes us to the 16th of May, so we're going through the month of May 2013 very gradually. Again, same idea, warm, cold and warmer up to the north or to the south of Greenland. So again we have got that tripole going on in the Atlantic up to the middle of May. What about going further on to the 23rd of May? Well, again it's the same idea. Won't highlight it this time, but I'll show warm, cold, warm. So again the tripole is there through to the 23rd of May. It's not especially strong tripole. It's not as strong as 2009, nor is it as strong as 2010, but it definitely is there. And then finally, just having a look at the very last chart, anomaly chart for the 30th of May 2013. And by the way, this comes from NOAA, it comes from NOAA. You can find these anomalies, or the link to these anomalies from my links page. Again, we'll just have a very quick look at this one, and it's the same idea. The warm anomaly through the tropics has faded a little bit, but it's still there more or less. The cold anomaly again has faded a little bit, but it's still there, and the warm anomaly to the south of Greenland has faded a little bit, but again it's still more or less there. So throughout we see more or less a tripole persisting in the Atlantic through May 2013. Now it waxes a little bit as we go on to the end of the month, so it's not a strong tripole lasting throughout the month as we saw in 2005, 1995 and 2010. It's not as good as that, but nevertheless the prediction from this has to be that you would expect a negative NAO. You would expect the tripole to re-emerge through the coming winter, the winter of 2013-2014. You would expect that tripole to re-emerge, and consequently you would expect a negative NAO for the winter of 2013-2014. So that is going to be the Gas Weather Vid's prediction. Based on this, yes, I'm going to say that we're likely to be seeing a negative NAO for the coming winter of 2013-2014. Now, need to put a few caveats in this. The first caveat I want to put into this is what's going on in the Pacific, because you'll have noticed, perhaps you'll have been looking at this very cold area that we've got going on here through the central part of the Pacific. That actually is La Nina beginning to show its hands a little bit through that central and eastern part of the Pacific. Now, if that was to intensify very, very strongly, whatever's going on in the Atlantic, it's likely that that would tend to override the signal in the Atlantic. So that's something we've got to keep an eye on. And generally, as I explained, there's a lot of other things that come into play through the course of the winter. We have to look at sea ice extent. We have to see how quickly the snow cover builds up over Siberia, solar activity. There's all sorts of things that we have to look at, and we won't know any of these until we start getting on into the autumn. So September really is when I'll start doing the proper forecast for the coming winter in the United Kingdom. This is just the starting point, and it is a small part of what will become a much bigger whole in the end. We'll get lots of things, put them all together, and we'll come up with a forecast at the end of November. This is just a small part of it that goes into that forecast. And you may say, well, why don't I just sit on this until September? And indeed, I could do that, but this wouldn't change. The negative NAO from this methodology from May, Atlantic sea surface temperature anomalies, wouldn't change in September. It would still be for a negative NAO. So why should I sit on it? Why not just share the information with you now, and then the information is out there, you know what that is going for. But yes, it's there's going to be lots of other things that become very important as we get through towards September, and that's really when I'll start doing the forecast for the coming winter. But anyway, just want to finish up with a summary. The GabsWeatherVids.com forecast for the North Atlantic Oscillation for the winter of 2013-2014, based on the sea surface temperature anomalies in the Atlantic in May 2013, is for a negative NAO. That is going to be the starting point when we come to do the seasonal forecast, when we start looking at putting everything together. That will be the starting point, that the Atlantic is in a state that should be projecting us towards a negative NAO for the coming winter. So if you like cold winters, it's good news for you, but it's not a done deal by any means. It doesn't definitely mean that the next winter will be cold. Please don't go running away with that idea. It's just the starting point. But nevertheless, it's interesting. I hope you found the video interesting and informative, and hope you're just perhaps a little bit excited about what the prospects for the winter of 13-14 may hold if you like it cold. That's it. Thanks for watching. Bye for now.